Welcome back. In our previous episodes, we explored the concept of G gravitational effects, how the projection, direction, and intensity of characteristic G waves influence our perception and cognition. But what happens when there's an error in fuzzy recognition? Does the gravitational effect still play a role? Today, we are diving deeper into this phenomenon to uncover the physical nature of G and G waves. At the heart of fuzzy recognition errors like this, although a specific G is activated, it doesn't actually correspond to the intended object. Yet, gravitational effects are still present because they are essential for fuzzy recognition to occur. When we realize that this is not that, it happens because the incoming G waves are compared to the activated G, and the two fails to sufficiently match. This comparison triggers a feedback wave that is projected to the neural display regions, allowing us to recognize the mismatch. After this process, the previously activated G adjusts its state, reducing its gravitational pull on subsequent G waves. This mechanism allows the brain to continuously self correct and refine its recognition process. So let's dig deeper into the origins of these gravitational effects. Scientifically, G processes electromagnetic properties, while G waves are essentially electrochemical signals. How do these signals interact with electromagnetic forces? Here's where the principles of electromagnetism come into play. 1. Electric currents generate magnetic fields, and currents in magnetic fields experience forces. 2. Parallel currents attack, while opposing currents repel. These principles provide a foundation for understanding G theory. G waves traveling along nerve fibers can be seen as specific electric currents, while the G's themselves may process unique magnetic fields. To better connect this with biology, let's examine how neurons transmit action potentials. When a neuron is strongly stimulated, depolarization occurs, creating opposing currents inside and outside the cell membranes. These opposing currents generate magnetic fields around the nerve fiber. If two Gs are activated simultaneously, their projection path may generate active or repulsive forces. These forces might play a critical role in forming connections between Gs. Furthermore, the electromagnetic nature of Gs means that when other G waves, like acting as specific electric currents, these G waves pass through their magnetic fields. Various physical and chemical reactions could occur depending on their comp- compatibility. This interaction might alter structural properties of Jews, explaining how they form, adapt, and evolve over time. Of course, these two interactions don't happen in isolation. Environmental factors such as bodily fluids, hormones, medications, or the surrounding network of Jews can all significantly influence the formation and modification of Jew connections. These factors might even lead to vastly different outcomes, highlighting the intricate complexity of the brain's interconnected system. The material world is governed by cause and effect. Complex physiological activities can be broken down into micro level physical and chemical reactions, and fundamental scientific principles emerge even in these intricate progresses. Just as simple arithmetic underlines advanced mathematical theories, so to do basic physical principles underpin the brain's operations. In the next chapters, we'll explore the activation states of Gs. Do Gs exhibit varying levels of activation, such as inactive, active, or highly active states? What governs their activation cycles, and how do they accumulate and release energy? Join us next time as we unravel these fascinating mysteries. If you are intrigued by the electric electromagnetic nature of G waves and their role in shaping perception and cognition, don't forget to like, subscribe, and share your thoughts in the comments below. See you next time. Bye bye.